So very good morning, and let's start with the day with the last chapter to be completed for today for PG1, which is lesson number 7, using SQL in SAS. So this is just an introductory part of SQL into base SAS. In detail of SQL will be taken care into your advanced topics where we'll be covering SQL in detail and macros in detail. Okay. So this is just an introduction that how one can incorporate a query language into SAS environment. So what is a query language? Actually, it's termed as SQL. So S stands for Structured Query Language. So query language is nothing but when we have our data or we have huge databases and we need to fetch in the information from this databases directly querying, or we can from the database itself you can pick up the required information, because database consists the information about your business which may have n number of tables with thousands of columns and millions of rows. So in that scenario, you may never have the information for your business scenario into a single table. You may have the information scattered in various tables. Suppose now you want to generate a report of employees where the employees needs the that means the management needs to submit or needs to email the employees whose birthday maybe is coming in upcoming month. Okay, now when I'm telling that I have the information for employees, like for example, I just share certain things. Let's use whiteboard to be shared. Okay, so for example, we have suppose a table here. We have another table. So we have various tables. Okay. Then again, we may have information. So as per our business requirement, our requirement is we have to have the information of employees for their upcoming birthdays in the upcoming month. Correct? Birthday cards needs to be emailed by the management. Fine. So this is our requirement. But when we say employees information in upcoming month for birthday cards needs to be emailed, so there is many info or many words which are not coming from a single table. You will have a data where you may have the information of employee, where this employee may have this, or he might be, or we may have the information of just employee. You have a data of employee. Now this employee data consists of the information of employees, that is their general information, that is name, okay, address, or simply name, date of joining, okay, date of joining, fine, and maybe which department they belong to, fine. The next information you may have is about those employees who are actually from various, or this is general, this is for a specific department. Okay, so this information is for specific department, so our requirement would be for those employees who are from the marketing department. Fine, your requirement is for marketing department. Fine, but we are having the information of employees throughout the organization from various departments. So and then you may have a specific information of employees, so have the information about their salaries. So salary may also consist of employee ID. Okay, so you may have the information of ENP ID. Then you may have their date of joining, or yeah, for this department when they might have joined. Fine. Then you may have about their bonus details. You may have their information about um, which date the salary may be credited, date of salary. Fine. And the third table would be the information about general information about the employees. So here you may have the information about the employee details. So employee details could be your EMP ID, name. Now here the name would be like you may have a column as first name. You may have the column as last name. You may have the column detail of suppose date of birth. Okay, you may have the detail of date of joining. You may also have the detail about the employees, that is their addresses. Okay, their physical address, their email IDs, their contact numbers. Fine. So this is what we have. But to achieve this information which we are looking for our business requirement, the things are not into single table. They are all scattered in different tables. So this is all saved into databases. Now this information is not only for a single department. You may have the department's information scattered all over your databases. So in that case, some of the information from your first table, second table, third table has to be jotted down, and then you'll get the required output, which is as per your table, which you might need to create so that it has been provided to your management. But to achieve these results, we'll have to write certain code where it will query first table, second table, third table, and put the information together, that is join the information together to get in the output. And that is where your structured query language plays most important role in this area, and therefore it is called as, or it is termed as, query language. You write a query to achieve the result, and it is directly written the query on your database. So databases could be your Oracle database, it could be your Teradata database, it could be your SQL server. We also term it as MySQL. You may have Sybase, you may have Hadoop, and many more. Okay. So these are various databases. So we never, from SAS, even if you want to fetch in the information to connect to these various databases like Oracle, Teradata, then either you'll have to write a libname statement to make a library into it, get it connected for the whole table. Now each table will have thousands of columns and maybe thousands of rows. And to connect each table into SAS via libname, it may take lot of resources of SAS to connect to this databases via libname. Are you getting what I'm trying to tell you? Yes,
Yes,
no,
ma'am.
Yes,
Pallavi.
ma'am.
Okay, so it's not feasible for us to every time get connected to this databases, which utilizes the huge space and your memory, or it could be like it's absolutely not at all feasible in that particular case. So in this scenario, we actually write a query, and the query is written with the help of a language we term it as structured query language. All right. So it's a proper structure where step by step you write certain steps. Now, first step is we start selecting columns, only those columns which we required to be queried. Then we provide from the input table which you need to query. Then in case if you want to subset your data, you write the subsetting criteria. In case you need to group your data, you write the group by criteria. In case you need to order your data, you write order by criteria. Okay, so these are the sequence of the query. Hence, this sequence has to be followed. Hence, it is termed as structured query language. So in this prompt table, you may have multiple tables like this. You may join one table, you may have second table, you may have third table. So at a stretch, you can connect various tables to get the information in a proper sequence, and hence it will directly, this code will connect directly, or we give instructions to connect those databases, and only required data is fetched into your SAS environment, and that data you can use for your report generation. And hence we never have it as or we use it as actually SQL is an external language, but we have incorporated into SAS since 1980s. It's been incorporated in within SAS, and it's doing giving a very good code developed for SAS, where you can query huge databases by writing queries within SAS environment, and hence the more detail of it will be learning into advanced SAS. But here it's just an introduction. All good? Fine. So let's have introduction to SQL query. So it's telling SAS and other languages. So yes, you can incorporate Python language, SQL language, R language, Lua, Java, and REST into SAS environment. In addition to working with other types of data, SAS also enables you to use your programming languages and APIs within SAS environment. So where does this SQL query language or program in SAS falls into are this 5 steps of SAS programming? It actually is, we utilize this into a process of preparing data and analyzing and reporting data. We are going to make use of SQL in this part of our programming structures. All good? So it's a structured query language. Actually, it's been developed into SAS with a step of proc. Okay. So we'll see how it works. And of course, either you can create a table or you can generate report out of it. So it's a language of most database management system defined by international standards. Yes, when you're writing queries into databases, it is termed as the query language, and it writes those codes and generates the output as per international standards, which are termed or which are put forward by NSI. NSI is nothing but it is American National Standard Institutes. Okay. And in SAS, it is available to be written with a proc step with proc SQL. Can be used as an alternate to your data step or certain proc steps. Syntax describes the desired output. So these are the some of the queries from the analyst or business requirement from the analyst. The analyst is telling, if you have SQL experience, you will be excited to learn how it integrates with SAS. And if you are not, you will learn here how you can write the SQL query into SAS. So as I said you, it's a structure. It has to be followed this order. Select, from, where, order by. And this whole thing is a single query. See, it ends here, and it starts with the procedure of SQL, ends with the quit. So within this pair of SQL and quit, you can write this multiple queries. All good? Same like this.
Yes.
With selecting the columns, your from clause, your where clause. Of course, what is group by, we'll see it in detail later, and of course, your order by clause. So this is what it is. And actually, when we work into SAS environment, actually, when I write proc SQL, it is a keyword. I write select, it's a keyword. Now, select is the select the columns to be queried. So in case if I write asterisk, it will select all the columns. From is to specify the input data file. pg1 dot class birth dates. Suppose we can take this. Class birth date. Okay. From table. Okay. And I simply end this query. And this query ends or step ends with quit, not with run. So see, this is select which ends here. So within select, you have all the clauses which has to be written. Suppose it's where clause, then order by clause. All right. So all this will be saying one by one. But this is when I execute it, just check the output, how it gives. So it actually queries all the columns and all the rows from your input table, which you have specified, which is pg1.class.date. Now, when we see the
Ma'am,
log, yeah,
actually, I can only see the white board.
okay. All right. Hope you can see the code now. Okay. So this is your
Yes.
SQL. So select, it's selecting all the columns from table and put. All right. So the result is like this. So this result is similar. What it is querying is it's querying all the data, columns and rows into your output. Okay. So if you check your log, it is not giving you any message that it is producing a result as with proc print, proc freq, proc means. It's because those are SAS procedures. This is a non-SAS language. It simply tells that this was the table and the procedure has been queried. Okay. So this is simply querying all the columns, all the rows from your input data. Now what where does is where actually, and this result is similar like your proc print of your base SAS. So if I write proc print data equal to pg1 dot class birth date run. So by default, proc print also provides the same list report as your proc SQL. Only the difference with proc print is it gives you OBS column, but in SQL, no OBS column. But if you want to see the rows by default, here you need to write the option in proc SQL called as number. So now when you re-execute this procedures, you'll find this is your proc print output where it's selecting all the rows, all the columns. Same, this is rows, which is querying all the columns and all 19 rows. So it is producing the same result as your base SAS proc print when you select all the columns from your data. Okay. So when I use where, so where is, I may say that now we have the columns into it like age, fine. So I may write where your age is greater than equal to 15. Same where you write it in your proc print as well, correct? So it's the same where which you write it in your proc print. And you execute. One second. Where is the error? I did not end this with semicolon. Fine. So when I get my proc print output, I get the original observation number at which the data is been subsetted. But here we do not see this. Why? Because it's a querying language which queries the table there and get the information. But here it is within the SAS environment, this data set is working. Are you getting the difference? It's within the SAS. This is the data set within the SAS. That's why we use the library. But this is treating as if it's a database. All good, but result is the same. Janet, Mary, Philip, Ronald, and William with the same number of rows. All good?
Yes, ma'am.
Okay, that's it. But yes, now, when I want to order my data, I want to order it in the descending order of age or ascending order. I use this order by age. But when I want to generate the proc print report in a specific order, there is a prerequisite that your data needs to be sorted first, then only it will be ordered into a specific order. But when you are writing SQL, there is no prerequisite that your data needs to be sorted. So it will arrange the rows in ascending order by default when we write order by clause. So this is the difference with your database procedures and proc SQL, that for database or sorry, base SAS procedures, you'll have to use multiple steps to achieve the same result. But here in a single procedure, you can get the same output. Okay, all good. So The prerequisite, if you want to generate the data in a specific order, you need to sort your data, correct? Out equal to sort class data by each, by default in ascending, and run. And this sort class needs to be used here to be sorting your data, and you'll get the result which would be same as your process SQL. See, and this is your SQL output. समझ में आ रहा है हम लोग क्या डिफरेंस कर रहे हैं? So base SAS
Yes.
procedures needs multiple steps. In Proc SQL, single thing can be appeared or can be done into single step. All good? So this is just what they wanted to introduce. So semicolon is the end of this select statement. So this is termed as select statement where it ends with this semicolon. So with a single Proc SQL and quit within this, you can write multiple selects. So now I can write another select where I can query a new query. I will write select clause. Now how I select the columns which I want in my desired output is here in proc print we use the var statement, correct? We use var name, we use suppose age, and we use birth date. Correct? But in select, the same thing is written in your select statement where I separate them by comma. All good?
Yes.
So in a single proc SQL, you can write multiple select, you can query a different table as well. Fine, now here I may write another result where it is less than equal to 15. Now I can query this. Okay, I have an error, column name, birth date. Let me check birth date. Now query. See, this is your first query result. This is the second query result where it is selecting only name, age, birth date, and all the students whose age is less than equal to 15. And this is querying all the columns whose age is greater than equal to 15. So both this query result, I see the output. All good? समझ में आ रहा है? That in a single proc SQL and quit, you can write multiple select statements, or we call it as a select clause. All good? Okay.
Yes.
So this is what it's telling. But what if I want to generate this report to understand what is this birth dates? Now we know this is your SAS dates in the form of number of days. I want to display it in a specific form, which is a readable form. So in base SAS with proc print, we write a format statement generally, correct? We write format, we write birth date, and we write date, 9, whatever the format which is required as per your business. But in SQL, you write this format in front of this column as format equal to, and you apply a format. Suppose you want it as DD, YY.
Sure.
Okay. So this is what you write format equal to. Okay. Now I re-execute this. See, now it's got formatted. 18/3/2007 is the birth date for this student. And so on. Okay. So this is the enhancement within Proc SQL. When you are selecting the column, in front of that column, you write format equal to. So this is applied on this column. All fine?
Yes, ma'am.
So that's what this code is also telling. It's applying that format. You select the columns separated by comma from clause. Fine? Yes.
Hello.
Yes.
if you wanted to find the frequency or univariate section.
That we'll see later. That is in more detail. We'll see it in into advanced SAS. Okay.
Okay.
So in SQL, it's not that you can always select only existing columns, but normally when we want to create a new column where you want to calculate this height into, suppose currently the height is maybe in specific unit. So if you want to convert this height into centimeters, so normally, if it was a data step, we'll have to create a new column into data step with an assignment statement with base SAS, correct? But when you're writing a query to be queried on a table, you can express that expression within this query statement and give this new expression as a new column name with this as keyword and give the column name like this. Okay. So what is it that we are actually converting this height from inches to centimeters to your new data. So here I can include that I want to have this new column. Now in case, one sec, in case I don't write this as, okay, and I write it in a separate column. Okay, so is this query I executed. So when I execute this query, comma, I'm missing this comma, because though it's an expression, it's going to be a new column altogether. Height into, okay. So in case I don't write like this, okay, and I execute my query will query all the columns, and the expression which I have provided, it's giving me the result of height, but there is no column name. So this is what SAS or SQL does, that the expression which is calculating a new expression for the, it's taking it as a new column to your output. So in case if you want to give the column name, you can write a keyword giving as means alias, that is a name for your column. You can write its height into centimeters. All right. So this is how in SQL one can also, while querying, create a new column to your output result. All good?
One doubt, ma'am.
Yes, yes, yes. Tell me.
Go to the line number 12.
Yes.
In the line number 12, we have raised a query for
Hmm.
numbers, and we
Number
have
means show the number, that is row numbers. Because
row
by default,
numbers.
yeah, by default, this query, does you get any row number here?
No.
So in case if you want to see the number from, this is the query result which we have seen here. So as with proc SQL, sorry, proc print, it gives us a default OBS column, correct?
Yes.
Right? But in SQL, it never gives you a row number because it is not querying. It's treating this table as a database and not an existing SAS table. That's why there is no number coming. It just selects the columns with and the rows as per your query instructions. But if you want to see what are the number of rows, you give this option called as number. Then
Okay.
this query result will give you the number of rows which have been queried. So this is not original rows, okay, from the table as we get with proc print. Proc print, it queries the data set, SAS data set. It's within the SAS environment. But this query means it's querying non-SAS tables as well. It treats this table as a database table. All good?
Yes.
Difference समझ में आ रहा है?
Yes.
All right.
Yes,
That
ma'am.
is all. Okay. So what you can do is try this. I'm giving you in the chat box. Understand the concept and try each code.
One more point, ma'am. Hello.
Yes, tell me.
Yeah, we have started our sentence by proc SQL
Hmm.
numbers, and then we have provided semicolon. Afterwards, we have provided semicolon in the order by age. So it will be treated as a complete one sentence.
This is one sentence. Selects ends here. That's what I said you. As per this slide also, select means it's a clause which ends by writing all this input clause and then afterwards writing including all the select clauses, the select statement ends here. That is
Okay.
what it is. Your select statement ends here after giving all these clauses.
Okay.
So this is one query. This is another query. So in a single proc SQL, you can write multiple queries. So this is termed as a query.
Okay.
Okay. And that's why it ends with quit and not with run. Quit means stop all at once. Run is only for a single step.
Okay.
All good?
Yes.
Okay. दीक्षांक दीक्षांक समझ में आ रहा है? Okay. So go ahead, try this code.
Yes, ma'am, done.
Hello, ma'am. Hello.
Yes, Pallavi.
Yeah, one doubt.
Yes, tell me.
Um, Code line number 12 to quit. Till quit, I have run the code
Hmm.
and I got the result. So first section I got is age is 15 and age is 16, wherein only 5 rows were present.
Hmm.
Whereas other table which I have got, it contains about 18 rows and age and birth date. So
It's
the
because,
codes,
if you have observed this where statement, it's telling age is less than equal to 15. Here we are
okay.
selecting age is greater than equal to 15. Are you getting the difference? And here it's
Yes,
selecting
yes.
all the columns. Here we are selecting only these three columns.
Oh, okay.
Got it?
Yes, yes, got it.
Okay.
It's done, ma'am.
Yes, Pallavi.
Yeah, done with it.
Done? Okay.
Yeah.
Just hold on. Huh? All right. I hope working on this query and observing the query code, you might have understood the difference with proc, print, and SQL. All good, Pallavi, Dikshant?
Yes, ma'am.
All right.
Yes, ma'am.
So this is what we had learned, that we can create a new query column by writing the expression into select. And if the same result has to be done with base SAS procedures, we don't have option to create new columns in base SAS procedure. For that, we'll have to write a data step, write an assignment statement, create that column, and that can be viewed in your report, right?
Yes, ma'am.
Yes, ma'am.
All right. So let's work on this activity. Now it's telling what are the similarities and difference in the syntax of two steps. Run the program. What are the similarities and difference in the result? It's the same thing what we have discussed earlier. In the syntax, to select the columns in proc print, we write a var statement. The columns are selected, and the order, of course, is been seen of the columns in the same order as you're writing here, but the columns are selected with space here with comma. We cannot use assignment statement to create a new column with proc print. Here we use it. Of course, here we need to write a format statement. Here it's an option in front of your column to apply a format. All good? So these are some of the changes in the code. Fine. So this what's all it's discussed. It's the same thing. We can subset your query result with a where clause. That's what it's given. And after this, your select, you can end your statement of select. And of course, if you want to order your data in a specific order, you can write order by. And descending is the small keyword. If we are not writing the whole spelling of descending in order by, post height, it is with proc print, we write descending as a whole word before the column, but here it is post column. So it is in descending order of your height, the query output. Okay, and it's the same demo. All right. Okay, so open this activity E02 for chapter number 7. So it's telling complete the SQL query to display event and cost from pg.storm damage. Format the value of cost. Now, before any time working on your scenario or on your table, the prerequisite, as I always say, first observe your input data. Your input data is damage, where it's talking about the damage occurred due to storm. So this is the event name, that is the storm name, the date when it has occurred, summary, it's describing how it has been occurred, and there is a cost which is been affected, and deaths, number of deaths. Okay. So as per this query, you have to, or as per this scenario, you have to write a query where they are telling us to select the query columns called as event, comma. Of course, the column has to be selected by giving comma into it. So it's telling display event and cost. So let's select the column as cost. Now from, without from, your select will not end. So from pg1 dot storm underscore damage and your query, and this is what you get the output. Of course, we have some syntax error with respect to your storm damage. So spell check for us and select it again. So when you execute, you get your query result like this. So of course, it's coming into exponential because of the width. Okay, so we'll have to adjust the width. So for that, let's go to this activity and read it in detail. Add a new column called as named as season that extracts the year from your date. So when you check your damage data, you know we don't have any season, but you have a date column. But date column never represents your date in a readable form. It's a SAS date, which is in the form of number of days. But you have to add a column called as season. But how do we get that season? So extract year, that is the function which is from your date, and give its name as season. So this becomes your new column. A new column is an expression. Again, the new column in select has to be separated by comma. So when I execute this and I check my output, I'll get season. So it's year which is showing at what year this event has occurred. All good? Then later on, done. Then it's telling add a where clause to return rows where cost is greater than 25 billion. So let's add a where clause. We have to select all the damage which has occurred, which is greater than 25. So write greater than 25 billion. Now, how many zeros with 25 billion? So this is 250, 2,500, 25,000, 2,50,000, maybe one more zero. 1, 2, 3, 4, 5, 6. Let's check. Fine. So this is all the damages which is greater than 25 billion. And then it's telling add an order by clause to arrange the rows in descending order of cost. So let's use the order by clause. Post where order by arranged your cost in descending order. So the highest will be at the top in your report and lowest in the bottom. So this is the highest first. So let's apply a format so that it can view in a readable form. So your cost, you apply a format equal to give a weight of 16 dot or 18 dot. Fine. So let's execute. Fine. So if you want to see, because it's a cost, instead of width, you can apply telling it dollar or comma. Okay. So it will just apply commas. All good?
Yes.
Diksha?
Yes, ma'am.
Fine. So this is how your activity should look like. Okay. So just type this code.
One query, ma'am. Hello.
Yes, yes.
Yeah, as it is not showing the OBS column, we are not able to utilize like OBS to, is equal to 2 or 4.
OBS comes only when it is a base SAS procedure. This is not a base SAS procedure. OBS comes with proc print.
Yes.
So
So
if you
if you
want to
want
see
to,
the number of rows, you just simply write the option as number and you'll
but
get the number of rows. But that is not original rows as I said you that this is just the number of rows which has been queried. Okay, of course this is from your table itself, but it's treating this as a no, as a querying table which is your base database table. Whereas with ProcPrint, it treats that input table as a SAS dataset. Though this is a SAS dataset, but it's a different language. So it's treating it a table and not a SAS dataset.
yeah, yes, ma'am, I agree with you, but my doubt is different.
Mm-hmm.
Yeah. In this base SAS, we used to utilize OBS is equal to 2, 4, 20, as much observation we require.
Mm-hmm.
But in the SQL, as we are writing over here as a number, if you want to select specific number of observations, so in that case, what need to follow?
You can write out OBS. So this all will be seen in advance. Okay, so I
Okay.
can write here suppose 10 rows. So out obvious, it's querying all the rows, but it will restrict the output only to 10 rows. Got
Okay.
it? And it will
Yes.
give you an alarm. So what that alarm comes? That statement terminated early due to out obvious. Why? Because it's querying your input table. All your SQL is giving you the result for all the rows just because you have asked it to stop giving the output only to 10 rows. It's just trying to tell you it's a warning. That's it. All
Okay.
good? So you
Yes.
can stop the rows up to what rows you want to display. All fine?
Okay. Yes. Yes.
Okay, so you can just work on this. Type it.
It's done, ma'am.
All right. Dikshant?
Yes, ma'am. Just a moment. I'm just.
Okay. I hope you are following what we have got introduced to SQL.
Yes, ma'am. I'm fine.
All
Yes.
right, good. So this is all
Yes, ma'am.
about,
Done. You can
yes,
continue.
great. So which is the biggest cost effective hurricane? It was Hurricane Katrina, correct? So in our output also we could see the same. It's Hurricane Katrina. What if we want to save this as a table, the report? So for that in SQL, you have a criteria where you can write this before select a statement called as create. Okay, you can write table. Give the table name as, suppose I give it as Hurricane as. So what this mean is that this syntax means that the upcoming query which will be queried, so instead of generating an output, save it as Hurricane. That's why it's telling create table name as, so this query result will be saved as a table. So now when I execute this, I'm going to see not an result, but I'm going to see an output data set. So it's having the same total 10. Why? Because it's an alarm. Why alarm? It's because we have terminated the output with only 10 OBS. So the data set which has been created will be only with 10 rows. And this is the data set. Now where this data set has been saved? In work library. So if you'll check your work library, you'll find this further. All good?
Yes, ma'am.
Understood? Yes. So
Yes.
this is just before select, you write this statement. Just add it in your code also and save it so that you are able to follow what you are learning. And write the comment what this output is doing for you. When you are practicing, it will be easy for you what it is, what number is doing. Okay, go ahead.
Hello, ma'am. Hello.
Yes, yes.
Yeah, if I run the program, no,
Mm-hmm.
I'm not able to view the results in the result section.
It won't come because the result has been directed into a table.
Okay.
So see, you'll have an output data tab coming up and you'll see the data set, not a result. Got
Okay.
it?
Yes, yes.
Dikshan?
Yes, ma'am.
All right. So let's move ahead. Fine. So this was the next thing. Creating a table at the beginning of the query turns report into table. That's it. Okay. Of course, now there is one thing with ProcSQL that if you want to delete a specific table from the memory, you can directly write drop table and the table name. It will remove the table from the SAS environment. All good? Now next topic is joining tables. Now this comes as if you remember one of the scenario which I had explained you with your whiteboard. If you could remember, I'll just show you that whiteboard. This one. So I have various tables. I need to join all this information to create a single output. So in your from clause, you can implement one or two tables to give the output. So when you are specifying the tables in from clause, the tables are also specifying the name separated by comma. All good? Understanding? Because till date, we have learned that SQL in a from clause, we were writing only one table. But what if you have the information scattered in various tables? So in that case, we need to join these tables. So for joining this table, we need to specify specific instructions in your from clause. Okay. So that's what the new topic we are going to just quickly go through it and then we can move to our basis. So now look at here. You have a data called class update and class teachers. You want to get the information combined that depending on the student's name, okay, you want their grades and teachers also. So depending on the information about the students from both the tables, common students' name which are there should align into an output where the same name student will have the grades and teachers as a new table where the common rows from both the data is aligning as a single row in your output dataset. So that is what we are selecting only the matching rows from both the data and it's termed as inner join in SQL. All good? समझ में आ रहा है? तो यहाँ पे नेम कॉलम कॉमन है तो डिपेंडिंग ऑन द नेम कॉलम the common values will get aligned into a new row as a horizontal join. That means your table is increasing sideways horizontally. So what are the names common in both the tables? Alfred, Alice, Barbara, Henry. So David does not have any value in teachers. Carol does not have any value in updates. So those are non-matches, but only matching rows are been aligned. Hence it is inner join. All good now?
Yes, ma'am.
Okay.
Yes, ma'am.
So that is what we are going to learn. And in your from clause, you are going to write the two tables. Either you write the tables separated by comma or you can input a syntax in from termed as inner join with this new data table, which is this on the basis of the common column, which is update, name. Okay. So I'll just show you this code, how it works. Fine. So instead of this, I'll use form. Fine. So when I don't use this information, okay, so I'm selecting grade, age, teacher. So if I don't use this also, I simply write asterisk. Okay. So in PG1, we have class update. Yes. Okay, so first of all, let's observe what class update has. 19 rows, 5 columns. Columns are name, age, sex, height, and weight. Fine, so this is update. And your teacher's data consists of name, grade, and teacher. And number of rows are again 19. Fine. So when I simply write asterisk and I select the two column tables, so I write a from clause. And in a from clause, I have the ability in ProcSQL that I can write maximum 256 tables in from clause separated by comma. Okay. So when I execute this, I'll get an output. So let's first understand what is the number of rows which is given. So I'm getting an output with number option so that I get to know what is the number of rows. So total number of rows after querying these two tables is telling 361. Now what has happened? It's because when I check my log, it's telling me execution of this query involves performing one or more Cartesian products, okay, that joins and cannot be optimized. So what does this mean? It means that when we have seen this result, it's reading Alfred. It's reading Alfred. Now look at the columns. First 5 columns are coming from class update. Next 3 columns are coming from teachers. So Alfred is combined with this first row. Alice is combined again from the first row from the second table. I hope you remember these tables. So we had update, which consists age, sex, age, height, Alfred. Okay. And
Hello.
teachers. Yes. Dikshant, I hope I'm audible. Pallavi.
Yes, ma'am.
Okay.
I can.
Oh, fine. All right. All right. So observe this. Teachers has 3 rows, 3 columns, and look at it. It has Alfred, Alice, Barbara. This is the grade. Updates also has Alfred, Alice, Barbara, but this is the value. But when I have written the code, I get the result. Alfred with the first row from your update class teacher data is good. Alice from the second table is good, but again I'm getting the first row from the second table, which is teachers. See, Alfred grade is 8, teacher is Thomas. The result is again Alice is combining with Alfred. Barbara is combining Alain again with Alfred. So what is happening? So this is termed as Cartesian product. Cartesian product is a default behavior of SQL joins when you write the tables to be combined in your from clause without any joining criteria. What it does is every row from the first table combines with every row from the second table, and that is what the result which you see is first row is combining with the or it's combining with the first row. Again the second row is combining with the first row of the second table again. So all 19 rows are getting combining with the each and every 19 rows of your second table. Are you getting it? So what is happening here? It's actually perform a Cartesian product, which you can actually term it as 19 rows from each table is getting multiplied with 19 rows from the second table, and that is why the result is 361 rows. Getting it? Understood? Yes, no. And this is termed as Cartesian product in SAS. All good? Yes.
Ma'am, just a request.
Yes.
Will you please explain it again?
It's simple that every row from the first table combines with every row from the second table. So if here you have 19 rows, so all individual 19 rows will combine with every individual 19 rows from this. That is what 19 into 19 is this, and it's termed as a Cartesian product. So if you see the result is the same. See, your first row from the second table is combining with every 19 rows. See, till here is the first table 19. See, Alfred is getting combined from the second table. समझ में आ रहा है?
Okay.
Again, now in teachers, second row is Alice, grade is 7, Evan. So the result which you see is now this Alice from the second table, second row is combining with every row from the first table. So from 19 till first 19 rows from first table is combined with first row from the second table. All good? Then the second row from your second table is combining for all 19 rows. So from 20 to 38. It's all 19 rows where Alice is combining from the second table. See?
Yeah.
So that is what it's doing. 19 into 19, total is 361. And that's what the result which you see is 361. And this is termed as Cartesian product, which is a default behavior. All good?
Yes, ma'am.
So until when you get this, when you do not provide any joining criteria, if no joining criteria is provided. Now we know what is a joining criteria. That means we know that in both the tables there is a common column, that is name. So we need to tell SAS both the tables have common column name and join on the common column. So I need to tell that class dot or class underscore update is a table dot name is same with your class underscore features dot name. Okay. So what does this mean? I'm telling SAS from this table, name is the column which is similar from this table. And now when I execute this, now check the number of rows. It will, okay, I have an error telling about this. Class underscore update dot name is same with this. Syntax error expecting one of the following. From clause here where we need to tell where. Okay, where we are telling that your table class update contains name which is same with your class teacher's name, and therefore it's termed as two-level table column name, table name dot column name. So now when I execute this, I'll get only 18 rows which are matching rows from both the data sets, and this is termed as inner join. All good now?
Yes.
Inner join is nothing but selecting matching rows. Fine. And look at the columns. It's selecting all the columns from both the data. Now you don't want all the columns. You may need only name, grade, and teacher. You can simply write it. The column names. Now name, grade, teachers. Teachers, teacher. Fine. But again, name is coming from both the tables. So when I execute this, it will select or it will give me a error telling ambiguous reference. Column name is in more than one table. So SAS is not understanding name to be selected from which table because it's a common column and it is available in both the tables. So let's select it telling that select from this table. So I can write it like this. And when I execute this, I will get the result that it will select name from one table and this is the output. Got it? But then every time writing the table name and a name, now this is a learning class or a classroom training. Therefore, you can write the name of the table, which is small tables. But when you're working in a live scenario, your table's name never sometimes be so small. So in that case, what you can do is in your from clause, you can give a nickname for your data. Either you write a word or a letter. So you can write as T. And instead of writing a whole table name, I write u dot name is same with t dot name, and here simply write u dot name is selected. And hence, you'll get the same result as you had in your expected outcome. All good?
Yes.
Okay. So this is one syntax for your inner join where you are selecting your common rows with using a where criteria. So you can also use an alternate syntax which is inner join and you give an on clause telling the joining criteria. So this is an alternate syntax which results the same result as you see with the where clause. All good, but here the column names they have given first is grade, then age and teacher, and here you are writing inner join. Result is the same, only the syntax is different. All fine?
Yes.
So just check it out with this syntax. Go ahead, work on this. Done?
Yes, ma'am.
Concept?
Yes, ma'am, it is clear.
Okay. So that was just introduction to inner join. Okay, that's it. So it's again the same thing. Again, see alias for your table. So instead of writing your table name, you give the alias to your table. That's it. Okay. So comparison of SQL and the data step is in data step, we provide more control of reading, writing, and manipulating data. It can create multiple tables in one step, includes looping and array processing. Whereas in Proc SQL, SAS standard language used by most databases, code can be more streamlined, can manipulate, summarize, and sort data in one step. So, though in ProcSQL you can do many things in one, but it's still telling data step and ProcSQL each have unique strengths. So it's you. This is not at all a replacement for your data step. Okay. Then, of course, in detail about manipulation of data will be learning in Proc 2, and in detail of SQL Essentials will be learning into your advanced SAS. Fine. So this is the end of this chapter. So for more learning, you can always read this link. So with this, we have done successfully with PG1. So we'll take a break of 10 minutes and we'll start PG2. All good? So it's 11:36. We'll resume at 11:46. All good? Take a break. So now with PG2 data and information whichever I have given regarding activities to be uploaded, data demo output. So for PG2 now you have to connect to your data folder for your library to be created named as PG2. So with this libname code and within this libname statement you add another libname which is for your PG2 data. So you will get another library in your session named as PG2. All good?
Yes, ma'am.
So this has to be done from your end. So if it is done, let's move ahead to understand what we are going to learn in your PG2. So just an overview what we are going to learn. So SAS programming 2 is nothing but data manipulation techniques. So in chapter 1, we are going to learn controlling data step processing. So here we'll understand that in PG1, we have just seen superficially that when you submit a step, there are two phases, right? Execution and compilation and execution. So we'll see how it is compiled and executed in the backend. We'll understand data step processing and we'll direct data step
Ma'am,
output. Yes.
ma'am, manipulation here doesn't mean that we have to manipulate the given data, right?
No, no.
Yeah.
In analytics, manipulation is not at all doing any changes in original table. Manipulating
Yes.
is just like whatever is currently existing, you're creating a new table as per your business requirement. That is
All right.
manipulating. All good?
Okay.
Okay.
Yes, ma'am.
Lesson 2 is summarizing data. In this, we'll see how one can create and accumulate a column and process data in groups. Lesson 3 will be manipulating data with functions. Here we'll see in more detail about implementing the functions. We'll see what is called routines. We'll see numeric and date functions, character functions, and we'll also convert with the column type with the help of some special functions. Column type means we know the column is always defined with its type, either its character or numeric. But sometimes a numeric column might have saved as character. So how to convert it into numeric and vice versa. Okay. That will be covered in lesson 3. Lesson 4 will be creating custom formats. Now this chapter is all about we will be learning how to create user-defined formats. Earlier, we had seen we are directly implementing SAS-defined formats. In this, we'll see being an analyst, a user, we can also create our own formats. Then, lesson 5 will be combining tables where you will be learning about merging your data sets and concatenating your tables. And of course, selecting matching and non-matching. Lesson 6 will be all about getting introduced to do loops. Okay, and lesson 7 is a restructuring table. Restructuring table is sometimes there is a scenario where your columns has to be converted to rows and rows to column. So there are two ways of restructuring. One is with the data step, one is with the proc transpose procedure step. That's it. 7 chapters to be covered in PG2. So let's start with your lesson number 1, which is controlling data step processing. So there are 3 topics in this chapter: setting up for this course, understanding data step processing, and directing data step output. So setting up the course, just a simple overview that we are learning with SAS programming steps, correct? And we learned into while programming, learning the programming, there are various steps of programming of your or you writing a program to fetching the information. So one thing is we saw accessing data, exploring data, preparing data, analyzing, reporting, and exporting. So PG2 is all about preparing data. Okay, so this is the area of your overall programming process where most of the part of PG2, that is data manipulation, is with respect to creating a business data. And this is the area in which we are going to concentrate much more, which is preparing our data. So to prepare this data, we'll see how one can explicitly write immediate processing observation immediately to an output data with an output data set. We'll also see how one can combine the tables. We'll see how we can use functions to convert character to numeric and numeric to character. We'll see how to create user-defined formats, which is custom formats. Then we'll see how to combine data vertically, that is concatenating, and horizontally, that is merging to create new data sets. And we'll also see how a looping process is occurred. And we'll see how to restructure the table where your columns becomes rows and your rows becomes columns and vice versa. Okay, so all this is preparing data, and in short, we are manipulating your table. All good? So during your training, the data which we'll be handling is, of course, you are quite familiar now. If we have international storm and weather data, we have US National Park data, we have European tours and trade data. Apart from it, some data which is outside your PG library, which is into SAS, which is cars, class, and shoes data. So yes, you are quite familiar during your training. You come across some demonstration activities and practices. Practices we do, we have 3 levels of practices. As per time permits, any one level will be doing in the class. Rest all would be your self-study. So we know programming interfaces are 3 softwares which SAS provides. One is your cloud application, which is SAS Studio, a windowing application, and enterprise guide. So we are maximum going to use, or we mostly use SAS Studio, which is a cloud application. Now you are quite familiar that of course data is saved for us or has been provided and segregated as per our activities, data, demos, and practice. So we connect to your data by writing a library or a libname statement to connect your data folder, and the naming conventions of files. Now it starts with P2. Why? Because it is PG2 course. Rest all is the same. Your code is always saved as .ss extension. So this indicates P2 lesson 4 demo D01. All good. So to connecting your data, we are going to write a libname statement to connect your data files. And that's it. So if you see the contents of your library, you will get this information. There are 56 tables. Okay. So how to check this? So once you have connected to your data, you simply see contents for your library by writing PG2 and dot underscore all underscore space NODS. So when I execute this contents, it just gives a report about the tables from your library. So if I scroll this, yes, I have so many information of my data files. All good? There are three types of catalog. If you overlook this, you will actually have the total files would be 56. Okay, that's it. Yes, so you have created a library. Okay. Now what they are telling with this activity is, if you open your storm summary table, you are now familiar that it consists of missing values. Character always represents blank, numeric represents with period. Correct? And of course, your basin names are in uppercase. There is values of basin which is in small case also. So how you'll overcome this in case if you required an uppercase basin in your output, you can always use a function called as uppercase on this column, right? And look at the dates. They are having the format which is applied. So if you see the storm summary table in your data in PG2, storm summary. Okay, so if you'll see this table columns actually are dates, but if you'll see its contents, these dates are applying a pre-existing permanent format with a format of date9 dot. Same is for end date. Correct? Agreed? So it is just to understand, or it's like a revision for the topics which we have come across from this PG1. That's it, and you have PDF book to follow. Now let's understand your data step processing. Okay. Now we know that when we are writing a data step, its main aim is that we are creating a new data file by reading from an existing data set. Now this data set is currently one of the existing table from a permanent library, and we are creating a temporary data set. Now you are including len, drop, where, basin equal to, you're upcasing basin. So it's an assignment statement. You're creating a new column. You are updating an existing column. Correct? Then you are subsetting, or you are creating a new column called as ocean, depending on this criteria of if then else. Correct? So this is most of the concepts are to create a new data with various instructions. So you are reading and writing table, you are filtering row, where is to filter the row, drop is to filter the columns. Then you are creating new columns, which is you are computing an existing column and you are creating a new column. And of course, you are conditionally processing your data. Correct? So it's all into a single step called as data step. So when you execute this data step, the result is an output data set, which is your one set. So the result is the output data set, that is storm complete. Agreed, everyone?
Yes.
Correct? Right. So So we know when I execute this, I immediately within seconds, I get a new data set being created. And it's giving us the instructions into SAS log that this is the instructions which you have executed. And at the end, it's telling there were 3038 observations read from input table, where name is not null. It has subset the data on this where criteria, and it has created a new data set with 6 variables and 3 not 38 rows. The result is an output data set. So it's within not seconds. So this is the default statistics which comes into your log. But when we execute this data step, what is happening at the back end? Being a data analyst, it's very much important for us to understand, and that is where we'll be learning about the process, how it works, and it helps us to correct the errors in case if we get in future. And that is what the aim is, that when you submit this data step, what we are going to look. Okay. So moving ahead, this is an activity. So just open this activity P201A03. Yes, Pallavi,
Uh, we just go to the result section.
there is no result, it's an output data set.
Yeah. So this there is much space in between.
Where is the space? This?
Yeah.
This space?
Name basing. Yes.
So it's a column. This is one column, this is second column. It's a table, right? And max wind is actually a numeric column, and numeric column always has the width of default 8 bytes. 8 bytes, it saves nearly 16 to 18 digits, but here are only 3 digits. Hence, it has this space like this. And numbers are always left aligned, correct?
Yeah.
That's all. All good?
Yes.
All right. Diksham?
Yes, ma'am, followed.
All right. So let's open this activity P2 lesson 1 A03. So it's telling run the programming and examine the log. Proc contains report and output table. So see, it's the same data step, and you are checking your contents and you are checking its output by writing proc print. So proc print is simple, your listing of your data, which we have created called as Tom company. Excuse me with this background noise, okay? Avoid that noise. Ignore it. So with this, I'm going to run it. So when a data step is created, now with proc contents, what is the area of your data which you observe?
Observation length.
So
Hello.
what is this? Proc contents actually results what? What is this? What you define this? We have already done in PG1. So in
Yeah.
short, what
Number
you
of
say? This is,
observations, variables.
so it's a descriptor portion, correct?
Yes.
And with proc print, you give it results all the rows and columns, which is your data portion.
Yes.
Agreed?
Agreed.
दीक्षांत समझ में आ रहा है? तो proc contents हमको descriptor portion देता है, proc print हमको data portion देता है, correct? Okay. So when we get this, okay, but yes, so now what they are telling with this activity, drop run, चलो क्या आया है क्या हमको? हमें तो कुछ नहीं आया. As per this activity, they are telling you now, move your drop statement to the end of your data step just before run statement. Run the program, examine the log. Proc contents report and the output. Did the result change? Now, what they are telling us, now we have seen this, right? In case if you change the position of drop only, no, or length statement. Drop statement to the end of your data step. All right, chalo, let's use this concept. Drop को before run में डालो. आउटपुट में कुछ चेंजेस आता है क्या both in contents and proc prints? Let's check. So it's not result. I don't think there is going to affect anything in your result as well as your contents. So it's giving you the same number of rows. So which column has been dropped here? We are dropping end date. So is your end date coming into your contents? No, it has been dropped. So there is no end date into it. And of course, we cannot see in your output data also. Fine. But now what they are telling is move your length statement. Yes, now you know what is happening with length. Last time we हमने देखा था. Length ocean you are telling is 8. Okay. Now I execute my data step along with my proc contents and print. And I'm going to get a warning. So let's check the log. So what is the warning it's telling? Length of character variable ocean has already been set. Use length statement as the very first statement in your data step to declare the length of a character variable. So what does this warning tells? We have done it in base SAS, PG1. Tell me what is happening if we change the position of length at the bottom of your data step. Drop का position change करने पर it's not affecting. It is still dropping end date. But length का position change करने पर it's giving a warning. And if you see the result, your data for ocean values are getting truncated. क्या हो रहा है? ये हमने PG1 में देखा है. चलो, tell me.
Hello.
Yes.
Yeah, we need to add this statement after the else Ocean Pacific. After that.
It should be as early as possible, immediately after your set statement. Why? Because when it is reading this data step in sequence, we had discussed that when we submit data step, it actually enters the compilation phase. So it's compiling what is required for the new data to be created. So when it is compiling and checking this statement, it is treating this as assignment. So ocean has to be newly created. So the length of ocean will be defined with the number of characters it first encounters. So here the number of characters are 6, correct? But then later on it is more than 6. So the length is already predefined. So when it comes across with this length statement, it will not understand it because the length is already predefined when it encounters the statement, and that is why this warning comes, and that is why the result of rest all the values are getting truncated. Understood? समझ में
Yes.
आया? So that is
Yes.
Yes, ma'am.
what is happening at the back end. वही तो हमको अभी सीखना है. So it was a warning. So the length of ocean is 6 instead of 8. Some values are truncated and there is a warning into log. Now why this is happening? Let's understand in detail the process of your data step. Now, when we submit your data step, we know there are two phases which is occurring at the back end, compilation and execution. So I've explained this compilation phase with an example of you are preparing a dish, suppose for a breakfast called as poha. So what you do is whatever it is, not only poha, it's general. It's a very simple example which I always give is whenever you're preparing a something, you start compiling the things, that is, you start jot down the things. So because it's the output you want it as poha, you first serve poha, you look into preparing the preparations like to chopping the onions and making keeping ready your pan and all these things, and then you start step by step adding the process of creating a poha. So output is adding the steps of adding the contents into pan is execution, and the result is the dish which is your poke. So that is what when a data step is processed, we have compilation and execution. So compilation is the phase where it establishes your data attributes and rules for execution. So what happens is in the backend is this. And once the compilation is done, then an execution starts, which is reading, manipulating, and writing data. So let's understand what and how a compilation is done. So compilation is that whenever we are now executing or we select this data step and we ask it to execute, when I press this button, it goes into the primary phase, which is compilation. So when it moves into compilation, of course, it's a data step. SAS always reads the step from top to bottom, statement by statement, from left to right. So when it is reading this during compilation, when it's reading this statement from left to right, it understands it's a data step. It has to create a new data set because there is no libref applied. That means this name of a data set has to be into a temporary data which is into work library. Set, when it comes to the statement set in the next line, it's an indication to be read from this data set. So what is the data set name? pg2.storm summary small. So it will go to this path and it will locate this data set. So when it is locating this data set, it looks into this data set, how many columns it has. Accordingly, when it looks into this data set, in this PDV, it creates those columns. So in the memory, it creates an area which is imaginary. Okay, we call it as program data vector. So vector is nothing but in scientific term is the carrier, correct? So here it will hold the memory by creating a space with a area termed as program data vector, where it will jot down the columns from input table. So it will read the column season, its type, its length. Next column name, its type, its length. Now because name is character, its type is defined with $sign. Here it is numeric n and default length is 8 bytes. Here depending on the number of characters, the length is 25 and so on. So it will from an input data, that is here we have the input data as storm summary small. So it will read all the columns in the area of the memory called PDV. So because those columns are existing columns from an existing table, its attributes are defined. So attributes nothing but name, type and length. All good? समझ में आ रहा है?
Yes.
So it's telling PDV is the magic behind data step processing power. So during compilation, it checks first for syntax error. It creates program data vector, which includes all columns and attributes from an input data set. It establishes the specification for processing data in PDV during execution. So ये जो space vacant है, that means every row from input data will be processed in this PDV during execution phase. All right. And thus, when it will read this, of course, this where is that it indicates as that it has to select name, which is not missing. So it should not select missing values. Okay. Now this is an existing table, a column. This is a new column. So how a new column has to be added, that we'll see later. And of course, when it encounters run, that means the compilation phase is over and a descriptor phase will, or a descriptor part will be created. Hence, it's telling descriptor part of your new data gets created. So how it works, look at here. So see, this is a compilation phase. It is into compilation phase. I've selected and submitted. So when it is in the memory, SAS reads the statement sequentially from top to bottom. Hence, first statement is read from left to right. So this indicates it has to create a new data set. No library assigned, that means temporary data set saved into work. Fine. Next step is set. Set means from input data. It is reading all the columns from input data. Existing table, hence these columns are existing and therefore they have predefined attributes, that is their name, type and length. All good? So it's inherited from input table. इतना समझ में आ गया?
Yes.
Dikshant?
Yes, ma'am.
So it's a compilation phase, correct? Now, next sequences, next statement, what it has in this sequence after set statement. Which statement it will encounter here? अरे आपके screen पे
Length.
है ना?
Length or
हाँ,
shape.
length, बराबर, length statement, because it's reading the data step sequentially from top to bottom, correct? So
Yes.
next sequence में कौन सा statement है? Length. So length,
Length.
and its instruction is ocean. Dollar indicates its character. Length is 8. Now length is there for ocean. It will first check into PDV. Is ocean already there in PDV? No. So it will add ocean as a new column, and because it's $8, it will assign its attribute. When SAS moves ahead, it will check whether any new column to be added. So it finds it's an assignment statement. Now, of course, this is also assignment statement, but it is existing column. If this is a new column. It will check whether storm length is already there in PDV. No, then it will add into it. So how it comes N and 8? Because it's an arithmetic expression. These two columns are numeric. It terms as numeric by default. Default length is 8 bytes. So each column must have at least name, type and length. All good now? समझ में आ गया?
Yes.
Yes.
ऐसे columns बनते हैं अभी. Okay. Now, is anything more to be added to PDV by looking into it? No. Then when it encounters the end of the step, okay, but before ending, it finds it has a drop statement. So it will flag D on this column in PDV. D means this column is to be processed. It's available in PDV, but when it is going to create a descriptor portion for this new data set, this column should not be written to your output data, hence it's flagging D. So drop or keep statement flags column that will be excluded to your output table. So when it encounters now run, okay, again it finds where, that means filter लगाना चाहिए. So PDV पे already filter लगाएगा that आने वाला table, जो आने वाला row होगा उसमें name is not going to be missing. तो ये वो already ये सब कंपाइलेशन फेज में करके रखता है. एंड अभी जब रन एनकाउंटर होता है तो फॉर योर न्यू टेबल अ डिस्क्रिप्टर पोर्शन इज created. And what is our descriptor portion? Which when we see it, when we use proc contents. Got it? तो proc contents में क्या दिखता है हमको? वही तो दिखता है, descriptor portion. Name of your data set, number of columns, number of variables, your type of data, where it is saved, correct? What is the path? Then its engine host and attributes of your columns. That is name, type, length and format. So ocean का length कितना है? 6. Why? Because यहाँ पे length statement अपना सबसे end में है. After reading set statement, it immediately encounters this. That is why ये ocean add होगा. Depending on the number of characters, उतना length define होगा. बाद में लेंथ आया है इसलिए अभी वो लेंथ एडजस्ट नहीं कर सकता है. अभी समझे why we are getting this error warning. समझ में आया?
Yes.
Therefore, it is recommended that length statement should not be at the end of your data step like drop, क्योंकि drop is simply dropping, वो चलता है, लेकिन length you are creating a new attribute for your column, so it should be as early as possible in your data set. So it's recommended to read it immediately after set statement. Got it now?
Yes.
And that is what we have our result now. Again, now I execute by adjusting my length statement. I'll find my contents for my data, which will show me the attribute for my ocean as 8. Got it? And not 6. All good? समझ में आया?
Yes, ma'am.
Okay. Dikshant. So this is how the descriptor portion of your data is created. Now, how a data portion is created? Well, now it moves into execution phase where it reads data from your input data step every row by row. Okay, fine. So when this is your data step, okay, again, when it moves into compilation phase, it reads your statements from top to bottom, from left to right. Okay, so when first data statement is read, it initiates that execution has to begin. When it moves to set statement, so when it initiates that the data step is to be begin to create a new row for this data set, your PDV has to be vacant. So it gets initialized to missing. So PDV actually क्या है? ये है. So ये जो है value, ये blank होते because every row is read here. So it has to get initialized that these values are initialized to missing. So that happens during execution. Then it will read a row from input table into PDV. Sequentially, it will process the statement and update values in PDV. At the end of the step, when it finished reading all the steps, it encounters run. So when run encounters, it's an indication to SAS that the data step is come to an halt. So the contents of PDV has to be immediately written to your output data set, and it is also an indication that this data step has to be processed again for upcoming rows from input data. Hence, with run, it implicitly returns back to process the next row from input data. So at the end of the step, it writes the contents of PDV to output data and returns to the top of your data step to again reprocess the data step for every row from input data. So in your input data set, if you have thousands of rows, every time this data step is processed 1,000 times. For each row, your data will be looped or iterated 1,000 times. Got it now? Understood? So automatic looping makes
Yes.
processing data easy. And that is why when we actually read your log of your data step, what we see is SAS tells us that a new data set is created by reading so many observations from input data. So that's what it's telling. There were 3038 observations read from input data set where it filtered the data and a new data set is created with so many observations on so many rows. So this is the result of your execution phase. And for every 338 rows, your this data step processed every time. That means 338 times. All good. So it is just happening with not seconds. That is execution phase. Fine. समझ में आ रहा है?
Yes, ma'am.
Yes, ma'am.
All right. Okay. Now, how you will see the sequence of its execution is happening at the back end. So for that, what I'll ask SAS is, in my set statement, I'll give this option OBS equal to, I want to process only 10 rows, okay? And I write here, I use a statement called putlog underscore all underscore. So what is this underscore all underscore and putlog? That means when my data step is processing, my execution phase for every row, I need to see into log. So I write put log and for all my variables. That is underscore all underscore period. So when I execute, I see the output immediately. So let's check my log. So see, my data step was processed. Because of put log, I get this is actually the contents of PDF. And by default in PDV, for every data step, I always have two variables created. Those are termed as temporary. Why? Because these two variables are never seen into output data. So what are these two variables named as underscore error underscore and underscore n underscore? So underscore error underscore indicates, do you have any error in your data? So the value is 0. That means currently there is no error. And underscore n underscore means this is the first iteration or first cycle of your data step. Why first? Because this is the first row which has been processed. Hence, its iteration number is 1. So because we are asking SAS from input data to process only 10 rows. So only 10 rows will be processed from input data. So your data step will be processed only 10 times. Hence, those 10 rows. So your total iteration cycles of data is 10. So this is a counter of data step processing, which is underscore n underscore. We are halting it only 10 observation. Understood? समझ में आ रहा है about this too?
Yes.
Okay.
Yes, ma'am.
So error always has Boolean expressions, 0 or 1. 0 means no error. 1 अगर आता है तो error has come. Okay, fine. Now moving to understand this. This is the contents of your PDV. So these are the column name. In first iteration, this is the value. Basin का column उसका value. And because you are creating a new column, as per this expression or as per your condition, currently आपके बेसिन की value I में है और Asian it's actually P. It's you're telling her why P it's taking specific because it is basin EP. और EP basin यानी क्या है यहाँ पे दिया है if sub str basin का second word वन लेंथ का वैल्यू अगर I हो या A हो लेकिन अपने ये वैल्यू में P है so these two conditions are not processed. It directly creates ocean with the value specific, and that's what you see specific. And storm length we calculate with you. And this is how a data set is created with your output. So with put log, you see the contents of PDB, how it is processing in the backend. All good?
Yes.
So either you can see all the contents or you can see one way or one at a time. That means you can write, of course, उसको हर वक्त आपको put log ही लिखना पड़ेगा. Put log और अगर हमको new column हम create कर रहे हैं, which is ocean, you simply write ocean and see the value. अगर आपको existing column का value अगर आपके current iteration में क्या है देखना है, तो you can write basin equal to. So with this, it will just show at every iteration these two variables into log. So when you check this output, of course, along with error underscore and underscore n underscore. तो वो हमने specify नहीं किया तो नहीं आएगा. तो first iteration में basin value EP है, इसलिए ocean बना है specific. Second iteration में SI है, that means second word is I, ocean is Indian Ocean. Now if you want to see that it's in which iteration, so you can write कौन से iteration में आ रहा है. So you can write underscore n underscore. So of course it will tell you it's in iteration cycle 1 or iteration cycle 2. See, in first row, second row, third row, that means first data processing, that is first row, second data processing, that is second row, and so on till 10th row. All good? समझ में आ रहा है ये सब कैसे हो रहा है? That is what is telling.
Yes, ma'am.
Or you can also check the message. So if you want to see that it's actually showing you the message, I can write put log. The message should be given in quotes and tell the PDB content of each iteration of data step. So I get this statement in my log. So at every iteration, I get this message in log. Why? Because I've written it, put log into this message. So I can check all the contents, I can check with the message, and I can check individual variable contents also. That is with put log. And that's what is all. All good? So if you don't have the interactive debugger, which is mostly in enterprise guide, you have this interactive debugger, which shows this is the content of PDB and how the data step every time process, how the PDB moves. लेकिन ये EG में है, so that is not there with us. So we see the contents in the backend with this programming way of looking into log by using put log and this on expressions. Fine. So this is the same thing which you are telling here. So for your understanding, I'll give you this checkout. I'll give you in your chat box. Just check this out, how it works. Check every statement, comment it for put log and see in your log how it shows. Go ahead. Done?
Yes, ma'am.
Good. Viksham? Okay, he's not at there. All right. So it's the same thing. Fine. Okay. So in this activity, it's A04. Let's see what they are telling us. So it's telling examine putlock statement that are in your data step. Add two putlock statements before run statement to print PDV before run statement. Write all columns in your putlock. Run the program. So this is your overall data step. Okay, in this. So we are going to write putlock. What is the statement they are asking us to write is PDV before run statement. Okay. And of course, they have asked us to read all or check all the columns into log. So we are going to write underscore all underscore. Fine. Now run and view the log. What is the value of storm length at the end of second iteration of your data step? So we are stopping the data to be processed from input data with reading only two observations. So we need to know what is the length of storm length. Okay, so let's check your log. So this is the statement. This is all the contents of your PDV. Okay, so you could see it is the first iteration cycle. So at the end of the second iteration cycle, what is the length of your storm length? It's telling length is 9. Okay, so okay, length is 9. Fine. Then type note. Use uppercase and include the colon inside the quotation marks of your following putlock statement. So we have to use this. Okay. We will be using this putlock statement now. PDV before run. Earlier we have PDV. We have PDV set statement. Okay, check this out. And then before run we have this. All right. So length is 9. Okay, in your second iteration. PDV before run. PDV set statement. So this is at every iteration, PDV after set statement. And this is the PDV before run statement. Okay. So what is it that we have seen? So note कैसे आता है? See, note comes like this. How note is coming? See, if you remember, we had one of the keywords of note. Hence, your note is coming like this in log. Now, why this note is coming in log? Because you have used this put log in quotes. Your note is a keyword which is in uppercase along with the colon. Hence, this statement along with note is appearing into log as if it's the note from SAS. कळलं काय केलंय आपण? पल्लवी, नॉर्मली आपल्याला नोट अशीच दिसते ना विदाउट एनी इन्स्ट्रक्शन्स. आपल्याला नोट अशीच दिसतात ना आउटपुट लॉग मध्ये, बरोबर की नाही?
Yes.
पण आपण
Yes.
हे मॅन्युअली टाकलंय आणि इट अपियर्स लाईक दिस ओनली ॲज इफ इट्स अ नोट कमिंग फ्रॉम SAS. आता आपण हे मॅन्युअली टाकलंय म्हणजे असं टाकलं होतं. वाय इट्स कमिंग? बिकॉज आपण हे कीवर्ड तसं तसं अपकेस मध्ये दिलंय विथ कोलन. त्यामुळे हे सगळंच ॲज इफ इट अपियर्स ॲज इफ इट्स अ SAS default note. That's it. They just wanted to tell that you can check this also. So now if I write another PDV, okay, now check this what I'm going to write, okay? I'm going to write here in uppercase. And I'm writing here.
No.
All right. Now I'm going to see the same thing into log. Now it's telling it's an error. Why? Because मी हा error message दिलेला आहे. And of course there is no error. But by default it's developed that the error whenever it appears, it should give its cross. Hence it's telling cross, but output is still coming because it's not a syntax error. It's just that a message you have typed with putlock to see the error as it is. So normally your errors also are in uppercase, are followed with colon. So anything written like this with your keyword also comes with that specific color, and it is a keyword. Color,
Yes.
that's it. So what is the value of storm length? You could say is 9. So adding the note, fix color codes that text as the note in the log. That's it and an exercise. So directing your data step. So exercise, आपण बघूयात, what's the time? So let's check your exercise for your lesson number 1. Yes, so this was the exercise. So set up a debugger execution. So because we are working into SAS Studio, it's not into EG. We are going to work the instructions with putlog statement. But here, so don't do this part because it's into EG. Come up with this second level on page 1-23. Go ahead, do this. Okay. So Pallavi, I hope you are able to work on this.
Yes, trying to. Hello. Hello.
Yes, Pallavi.
Yeah. In the first set, examine the program and answer. The second part I have done, but which statements are compiled timeout only?
So
So
compile means what? It gets compiled, na? So that means it's creating a PDV. So all these columns which are coming from an input data set are your compile time statements. And of course, your assignment statements where you're creating a new column. Those are all created at the time of compilation in your PDV.
which statements are compiled time only? Okay.
So your assignment statements. And of
Assignment
course, your set
statements.
statement. Set statement, it reads all the column from input data. Hence, it is compile time statement.
Okay.
Your
Modif.
PDV creates during compilation, right?
Yeah, yeah.
Yeah.
Actually,
Next.
I have done it. I'll provide the code in the chat box.
No, it's okay. Then modify the program to resolve the truncation of size. म्हणजे काय करणार तू लेंथ
Length.
adjust करणार बरोबर
6 is the 6 and dollar sign.
बरोबर
Modify the program, resolve the truncation side, read the first row from the input table.
so how you'll read only first 5 rows set statement
Observe
मध्ये OBS equal to 5 set
5.
statement मध्ये okay
Yeah.
Hmm.
Add the putlog statement to provide the following, that putlog, then note, then a data step iteration.
बरोबर
iteration.
correct that's
Then
it.
afterwards, after the type assignments, write the value type to log.
म्हणजे हे
So
असाइनमेंट स्टेटमेंट दिलं की त्याच्या खाली पुटलॉग टाईप इक्वल टू असं लिहायचं म्हणजे तो टाईपची व्हॅल्यू लॉग मध्ये देणार
okay, and run the program.
that's it
Okay.
fine
Yeah.
okay so that is just to debug the code. The directing data step output is actually a topic where every row जेव्हा तो प्रोसेस होतो आणि जर तुम्हाला एक्सप्लिसिटली त्याचा आउटपुट हे आउटपुट डेटाला इमिडिएटली लिहायचं असेल तर ते कसं लिहायचं बट आय वोंट गो इन टू डिटेल ऑफ दिस बिकॉज इट विल टेक अ बिट टाइम अँड इट विल बी बॉम्बार्डिंग ऑन युअर ब्रेन सो विल स्टॉप
Okay.
फॉर द डे this topic will continue next Saturday with the continuation of this and starting with your second chapter. All good?
Yeah. Okay.
Okay, so for today, we'll end our day. Enjoy your Sunday. Bye and take care. Thanks for attending the class.
Yeah.
Bye.
Okay. Thank you.